Hi, Stephanie from DesignCode. In this tutorial, we're going to build a fun application, a trivia game. This application will require an HTTP request to get the question and answers from an API, and we'll also need to code a bit of logic to take care of all the possible outcomes of the game. So without further ado, let's dive right in. So what are we going to build in this trivia game tutorial? We'll start off by coding the welcome view, which is this view that you can see here. And when we click on Let's Go, it will move to the question view. In this question view, you will be able to see your progress in the game, as well as the question and the possible answers. So for example, I will answer this question. Seoul is the capital of North Korea. So this is false. I will click on false, and you can see that since this is the correct answer, we have a green shadow around our answer row as well as a check mark at the right corner. If I have selected true, which is the incorrect answer, the shadow will be red with an X instead of a check mark. Then I will be able to click on next and it will move to the second question. So let me answer all the questions quickly so that we can see the end screen. So you can see that now I completed the game and I reached my end screen, which congratulates me and tells me that I finished the game. And we can also see my score displayed at the bottom here. And we can also play again, so it will refetch another trivia game from the API with different questions. And you can see that my game started again with a different question. So we'll need to code all the logic to go from one question to the other and to calculate the score and the progress as well. Since we'll be using some new features introduced in iOS 15, make sure to have Xcode 13 installed on your computer because iOS 15 is only available from Xcode 13 and higher. If you followed my other tutorial videos, I would say that this application is one of the most complex because there's a lot of logic to cover. So let's start straight away. To build this application, we'll be calling the OpenTrivia API, which is a free API that lets us query random trivia questions. The good thing about this API is that we can head over to their API page and we can pinpoint specific types of questions that we wish to fetch. For example, we can increment or reduce the number of questions that we want to fetch. We can also select a specific category, a level of difficulty, a type, as well as an encoding. So in my case, I will leave all of these options as is, and I will simply click on Generate API URL and I will get a URL here. We'll get back to this API later on. Let's start by creating our Xcode project. In the model that appears when you launch Xcode, click on Create a new Xcode project. In here, make sure to be under the iOS tab and select App, then click on Next. You will need to give your product a name. In my case, I will name it Trivia Game Demo. Select your theme, set your organization identifier, which is the reverse of your URL. Since our URL is DesignCode.io, we will write the reverse of it, which is io.DesignCode. The interface should be SwiftUI and the language should be Swift. Usually these are the default values, so you don't need to change anything. Then click on Next. Select where you want to save your project and then click on Create. The first thing I like to do when creating a new project is to change my target device. Instead of iPod Touch, I will select an iPhone 13. Then I like to close this panel and to resume the preview to make sure that everything works. Now that we see the hello world, we know that we successfully created our application. You can make your application feel more like a real application by adding icons to your project. So simply click on the Assets folder, then under App Icon, and you will see a few empty slots and a specific size for each slot. So you will need to create an icon for each of these sizes and then drag and drop it into their specific slot. This is the icon that will be displayed when you install the application on the device or on the simulator. So now that I added all the icons in my app icon folder, let's start by setting up the accent color. The accent color is the default color we will see on the buttons of our application. So simply click on the accent color under the assets folder and we'll click on universal so we can only set one accent color. Next, open the Attributes Inspector. Make sure you're under the last tab, which is the filter symbol, and this is the Attributes Inspector. We'll need to set a custom accent color. Under the color section, we can select some default colors from Xcode, but we want to set the accent color as the lilac that you can see on our logo here. So I have my hex color code and I will simply need to set it for the accent color. Make sure to select universal, and then under color, we'll need to select extended range sRGB. You can set the color with RGBA here, but since I have a hex color, I can click on show color panel, and under RGB sliders, we have an option to set our hex color here. So you can see that I added my lilac color, and now this will be my accent color in my entire application. If you wonder what the code for this color is, it's 9E6B93. So you can copy this or simply set an accent color of your choice. We'll start by coding the welcome screen, which is the first screen the user sees when they launch the app. This screen will contain a title, a subtitle, as well as a button that will start the trivia game. So let's go back to Xcode and we'll code the button as a component since we will use it at multiple places. So under the trivia game demo folder, let's create a new group called component because we'll have a few components in this project. And then we will right-click the components folder and create a new file. It will be a SwiftUI view and we'll call this primary button. Then let's click on create. This button will accept two arguments. The first one will be a text, which will be a string, and we'll also have another optional argument, which is background, and it will be of color type. We'll set it by default to a color, which will be the accent color. So the background color of this button will be lilac. Then remember to also pass the text argument for our preview so that it works and Xcode won't complain. So let's pass next as a string to our button component so that it silences this error. Now, instead of displaying the text hello world, we will remove the string and display the text that we passed to this component instead. Then let's add a foreground color of white with some padding around it, and let's also add some more horizontal padding. The background will be the background variable of this component. We'll also add some 30 pixels of corner radius and some shadow with a radius of 10 pixels. Now we're ready to code the actual welcome view. So since we will have a few views in our application, let's create a views folder. So we'll right-click the Trivia Game Demo folder, create a new group that will be called Views. I would simply drag it and drop it right before the components, and also drag and drop the content view inside of our Views folder. Let's open the content view and we will be coding our welcome view. So let's remove the text hello world and add a VStack with some spacing of 40 pixels. On this VStack, we will add a frame with a max width of infinity and a max height of infinity as well, so that it covers the entire screen. We'll also add the edges ignoring safe area.all so that the safe area at the top and at the bottom of the screen are also covered by our background color. We'll add the background modifier and provide a color. I will use the same background color as for my icon. So since I already have this color, I will simply paste it here, and you can copy this or set any other color that you wish. And you can see that it's a light yellow color. Inside of this VStack, we will create another VStack, which will be the top portion of the screen. So it will contain our title as well as a subtitle. So we'll add a VStack with some spacing of 20 pixels. Inside, we'll display a text that will say Trivia Game. And we'll add some font of title. We'll change the font weight to heavy. And the foreground color, we'll set it to the accent color of our application, so that it is lilac. Right below that, we'll display our subtitle, and it will say, "Are you ready to test out your trivia skills?" ? Let's also change the foreground color of this text to our accent color. Then right below that, outside of our VStack, we'll display our primary button. Remember to pass a text, which will be, "Let's go." So now we finished coding our welcome view. However, you can see that we added 3 modifiers to our title. We'll be reusing the same modifiers we added to our title for different views, so we could create a component, or we can also create an extension out of it. This extension will allow us to just code 1 line of code instead of 3 lines every time. So let's create a new file under the Trivia Game Demo, and this time it will be a Swift file. Let's call it extensions and create it. At the top, remember to import SwiftUI because we'll be creating an extension on the text view, and the text view only comes with the SwiftUI package. So let's write extension text. Inside of this, we'll create a function and we'll call it lilac title, which will return us some view. So the lilac title will be our custom one-line modifier. We need to call this on a text. Let's write self, which is the text on which we call our lilac title modifier. Then let's head over to content view and we'll simply need to copy these 3 lines of code and then paste it after self. So right now, every time that we call our lilac title modifier on any text, it will change the font to title, the font weight will be heavy, and the foreground color will be the lilac accent color that we set at the beginning. So let's test it. Let's go back to content view, resume our preview, and then we'll remove these 3 lines of modifiers that we added to our title. Instead, we will call the lilac title modifier that we added, and you can see that we still have the same styling for our text that we had before with the 3 lines of code. Great, we completed our welcome view. Now, once we click on the Let's Go button, you will land on the question view. So let's code this view now. This view is where we will see our progress, the question, as well as the multiple answer choices. For now, because we didn't code the HTTP request to fetch the questions and answers, we'll just hard code the text. So let's create our file in which we will code our question view. Under the views folder, we will right click and create a new file. It will be a SwiftUI view and we'll call it question view. Then let's click on create. Inside of this view, let's remove the text hello world and add a vstack with some spacing of 40 pixels. Then on this vstack, we'll add some padding, a frame with a max width of infinity, a max height of infinity, and we'll also set a background color. So the background color will be the same that we coded in the content view. So let's simply go there, copy this code, and paste it in our question view. We will code the top portion, which is an H stack that contains a title and the current question that the user is answering. So inside of this V stack, let's add an H stack. We'll have a text that says trivia game, and we'll reuse the one-line modifier that we created in our extensions file a few minutes ago. So it will be lilac title. Then we'll add a spacer and another text that will tell the user which question they're answering. So let's simply hard code 1 out of 10 for now, but it will be dynamic once we fetch the data and coded the logic as well. Let's set the foreground color of this text to our accent color with some font weight heavy. Now that we finished the top portion, we need to display our progress bar. So we'll create it as a component. Under the components folder, right-click, create a new file. It will be a SwiftUI view, and we'll call this file progress bar. Then click on create. This progress bar will take 1 argument, and the argument will be a progress. It will be of CGFloat type. CGFloat is a number with some decimals, and we need it as this type because we'll pass it as an argument to our frame, and the frame will accept only a CGFloat number for the width. Remember to pass the progress to your preview, so let's pass the number 10 for now. So let's remove the text hello world and we'll add a Z stack with some alignment to leading. Inside of this V stack, we'll need to create 2 rectangles. So it will be 1 rectangle on top of the other since we're in a Z stack. The Z stack works in 3 dimensions and everything you add will be on top of one another. So the first thing you add at the top will be the most at the bottom, and the last thing you add will be at the most top of your view. So let's add the bottom rectangle first. We'll add a frame with a max width of 350 and a max height of 4 pixels. We'll change the foreground color to a light gray with some opacity. So you can see that it's a light gray here. I just pasted the color that I already had, but if you want to set your own, you can simply make sure that your cursor is on the foreground color modifier and open the attributes inspector, and you'll be able to set a custom foreground color with the color picker here. Now let's just add some corner radius of 10 pixels so that the borders are a bit rounded. Right on top of this first rectangle, we need to add another one. So let's add a rectangle again, and you can see that by default, the rectangle in SwiftUI is of color black, and it went on top of the other rectangle. So let's simply add a frame with a width, and the width will be the progress variable that we added to our component. The height will be of 4 pixels. We'll change the foreground color to the accent color of our application, and we'll also set some corner radius of 10 pixels as well. So right now you can see a bit of lilac color at the beginning that is the width of 10 pixels. We can change the progress to, let's say, 50, and you can see that the top rectangle has increased in width. Now let's go back to our question view, and we'll call our progress bar right below our H stack. So progress bar, and remember to provide a progress. For example, let's provide 40 for our progress. And you can see that we have our progress bar now in our question view. Then below this progress bar, let's display a question. So let's add a new VStack right below the progress bar with some alignment to leading and some spacing of 20 pixels. Inside of this, we'll display a text with a hard-coded question for now. What we can do is to head over to the OpenTrivia API and make sure that you're under the API tab, and you can set your options for the questions that you want to fetch and then generate an API URL. We'll copy this link and then go to this link. Here you will be able to see the JSON data that will be returned when we call this endpoint. If you wonder how I get my JSON data to look like this, I'm using Chrome and I'm using an extension that is called JSON Formatter. So I highly encourage you to download it if you're using Chrome and you want your JSON data to look nice in the browser. What we can do is copy one of these questions and then we will paste it as a string for the question. Then let's change the font to a system size of 20 pixels. Let's make it a bit bold, and we'll also change the foreground color of this text to gray. Right below our question, we need to display each answer choice in an answer row, which is a component that we will create. However, before creating that component, let's create our answer model first. Let's create a new group called models. Inside of that group, we will create a new file, and it will be a Swift file. Let's call this file answer. This model will tell Swift which variables each answer object must contain. So every time that we will create an instance of answer, we'll need to add these variables. So let's create a struct called answer, and it will conform to the identifiable protocol. Identifiable protocol means that each answer can be uniquely identified by its ID. So for each answer that we'll create, we will generate a random UUID, which is a random ID that Swift will create for us. The answer structure will also contain two other variables. The first one is a text, which will be of attributed string type that we will see later on more in detail. And we'll also have a isCorrect value, which will be a Boolean value. So if the answer is correct, it will be true. And if it's not correct, it will be false. Now let's create our component. So under the components folder, we'll right click, create a new file, and it will be a SwiftUI view. We'll name this file AnswerRow and click on create. This component will accept one argument, which will be of answer type. So let's write answer, and it will be of answer type. We're able to have a custom type here since we created our answer model in the answer file. So now we have an error for our preview, and it says that it requires an answer and we didn't provide any. So let's insert an answer, and we'll need to create an instance of answer. To create an instance in SwiftUI, you simply need to call the type and then add parentheses at the end. For our answer, we need to provide a text, which will be a string, and an isCorrect value, which will be either true or false. So for the text, let's simply write something random, and I will write single, and it will be false. Let's remove the text hello world, and we will add an H stack instead with some spacing of 20 pixels. On our H stack, we will add a few modifiers. So we will add some padding all around the H stack with a frame with the max width of infinity and an alignment to leading. Then we'll set the foreground color of the text to our accent color. Our background will be white. We'll also add some corner radius of 10 pixels and some shadow. So instead of selecting the shadow with only the radius, we'll select the second one because we'll change the color of the shadow later on. But for now, we'll add a gray color for the shadow with a radius of 5. For the X, we will write 0.5, and for the Y as well, it will be 0.5. Now inside of the H stack, we will need to add an image of a dot. So we'll do image and we'll take an image from SF Symbols. So I will simply open the SF Symbols application and I will search for a circle. And we'll select this one, the circle.fill. So I will right click and copy the name. And then back in Xcode, I will paste it in my double quotes. We'll simply reduce the size of this image. So we'll do dot font, which will be caption. Right below that, we'll display a text and it will be answer.text. Let's make it bold. Now in this view, we will need to create an isSelected private state at the top. So add state private var is selected and by default, it will be false. This state will let us know if the user selected that specific answer row and will toggle the isSelected value on tap gesture of the row. At the bottom on the H stack, let's add the on tap gesture modifier and isSelected will be true when the user taps on that row. Now, if the isSelected is true or the answer is the correct answer, we will want to display an icon at the complete right side of the row. We'll also want to change the foreground color and the shadow's color. So first, we'll need to create two variables at the top for a custom green and red color. So I already have these colors and you can simply copy this one or create your own custom colors. So I will have a custom green and a custom red color. Then right below the answer text, we will add an if statement. So if isSelected is true, we will add a spacer and then we'll add an image. The image will be an image from SF Symbols again. And we want to add a ternary operator. A ternary operator is like an if statement, but as a one-line code. So we want to check if the answer is correct. If it's correct, we would want to display a check mark. So let's go to the SF Symbols app and we'll search for a check mark. So you can choose whichever you want, but I like this one, so I will copy the name and then paste it here. Otherwise, if the answer is not correct, we would want to display an X. So let's go back to SF Symbols and search for an X. And I will select the X circle fill. So I'll copy the name, go back to Xcode and paste it here. For this image, we want to display the image in green if the answer is correct and in red if the answer is incorrect. So let's add the foreground color modifier and we'll call answer is correct. If it is, we'll call the green variable that we created on line 14. Otherwise, we will display a red color. Now let's test out this code. We will play the preview and then tap on our row and we can see an X red image on the right side of our row. Now we'll also want to add some ternary operators to the modifiers that we added to our H stack. We will want to change the foreground color to gray if it's not the answer that the user selected. So we will check is selected. If it's true, we will keep the accent color. Otherwise, we will display a gray text. For the shadow, if the answer is the one the user selected, we will check if it's the right answer and display either a green or a red depending on the isCorrect value. So we want to check if they selected this row. If it's true, we want to call answer.isCorrect. If it's correct, we want the shadow to be green, otherwise red. To make this double ternary operator clearer, we can add some parentheses here. So if it's selected, we want to check another condition. And this condition is to check that if the answer is correct. If it's correct, the shadow will be green, otherwise it will be red. But if the user did not select this row, we will display a gray shadow on the row. Now let's go back to our question view. So I accidentally closed my tab and I cannot find back the answers to this question. So I will copy another question and then paste it here. And I will also add the answers corresponding to that question. So I queried another time the API and I have a question here, which is balls are attracted to the color red. So let's copy this question and I will change it here. Then right below that, we'll need to call our answer row. Remember that we need to pass an answer there. So we will hard code an answer for now, but later on, when we fetch the API, we won't hard code these answers. So answer, remember that we need to provide a text and an is correct value. If we take a look at the JSON data from the API, you can see that we have a correct answer, which is false, and an incorrect answer, which is true. So for the text for the first one, it will be false, is correct, is true. And we can copy this, paste it another time. Answer is true and is correct is false. If we resume our preview, you can see that we see the rows here. And we can select either one. So let's say that we think that the answer is true. We'll click on that. And you can see that the shadow changed to red. And we also have an X at the right side of our row. Then we'll also add our primary button below the VStack. So we'll call our primary button and the text will be next. Right below the primary button, we'll add a spacer so that everything is pushed to the top of our view. Now, there's no way for us to navigate from the content view, which is our welcome view, to our question view. We'll need to create a navigation link that links these two views together. However, let's create a bridge view, which will be called TriviaView, and we will link the content view to the question view in our TriviaView. So under the views folder, we'll right click, create a new file. It will be a SwiftUI view and we'll call it TriviaView. Then let's create it. We're creating a TriviaView because we'll need to add more code to it later on. For the moment, in this view, let's remove the text hello world and just call our question view. Now let's go to our content view and we'll need to wrap our entire body in a navigation view. This will allow us to use navigation link and navigate from one view to the other. There's an easy way to wrap everything in a navigation view. So we can simply click on Command on the keyboard and then click on our VStack and then embed this in any one of them. Let's select HStack and we'll change the HStack by a navigation view instead. Then we'll need to wrap our primary button in a navigation link. So we'll do navigation link. And we'll also have a label. Let's add the primary button inside of the label closure, and for the navigation link, the destination will be our trivia view that we just created. So let's run the preview here, and let's click on the Let's Go button and see if we're navigating to our trivia view. And you can see that we see our trivia view. However, you see a back button at the top with a lot of padding. As we don't need the back button, let's hide it with a modifier. Let's go to our question view, and on the VStack, we'll add the navigation bar hidden modifier and set it to true. So if we go back to content view and test out our code again, and we don't see the back button anymore. We don't want the user to navigate back to the welcome view when they already started the game. Great, now that we've finished the basic UI, let's call the API and code the logic. We'll need to add more UI later on when we'll polish our application. But for now, this is enough, and let's create our TriviaManager. Before creating our manager and calling the API, we'll need to create our Trivia model first. So under the models folder, we will create a new file. And this file will be a Swift file, and it will be called Trivia. We'll follow the structure of the JSON data we'll get from the OpenTrivia API. You can head over to this link here and follow the structure of the results array. So back in Xcode, we'll create a structure called trivia, which will conform to the decodable protocol, which means that we can get JSON data that will follow the same format, and we are able to decode that into Swift objects. As you can see in the JSON data returned from the API, we have a results array. So the first thing we need to do in this struct is to create a results array, which will be an array of result. And right below that, we'll need to create a struct called result, which will conform to the decodable and the identifiable protocol. You'll see an error that the result structure doesn't conform to the identifiable protocol, and even in the API, there's no ID for each question. But we will fix that later on. We'll just need to add a category, a type, a difficulty, a question, the correct answer, as well as the incorrect answers first. So let's add var category, which will be a string, then a type, which will also be a string, a difficulty, which is a string, then a question, which is also a string, then a correct answer, a string, and a var incorrect answers, which will be an array of strings. Now we'll need to add a few custom keys to the trivia model. So inside of the result struct, on the first line, we'll add a new key, which will be an ID. So var ID will be of UUID type. And since there's no ID in our JSON data returned from the API, we'll need to set it ourselves every time that we create an instance of result, so that we don't run into an error saying that the coding key ID cannot be found. To set it directly inside of our model, we need to add a closure, and inside of the closure, we will need to set our variable. So we will write UUID with parentheses at the end so that we create an instance of a UUID. We'll also need to do the same and create two other custom coding keys. The first one will be a formatted question, which will be of attributed string type. If we take a look at the API, you can see that sometimes the question that is returned will have some symbols and it will be hard to read if we simply keep them as strings in Swift. So we will need to convert them into an attributed string, which is new since iOS 15, and it allows us to convert Markdown, which is this here, into a string. To do so, we will add a closure here, and we need to wrap everything in a do catch statement because creating an attributed string might throw an error. So do catch, and if we run into an error, we will print it. Print error setting formatted question, and we will print the actual error. We'll also return an empty string if we weren't able to set it. Then in the do, we need to do try attributed string with parentheses, and we need to provide a markdown, which is a string. So we will need to pass our question variable, which is a string, and it will format our string. In this case here, instead of displaying equals QUOT and a colon, it will show a double quote instead. So we'll need to add the return keyword right before our attributed string, and it will silence all the warnings and errors. Now we'll also need to create one last custom coding key, which is an answers array. So it will be an array of answer. We need to create a custom answers variable because we don't want to always call the correct answer and the incorrect answers in our views. So this will allow us to centralize all the logic in our model, and we won't need to take care of that later on. So we'll need to wrap everything in a do catch statement inside of the closure of the answers as well. In the catch, we will print the error if we run into one, so error setting answers, and we'll print the actual error. If we run into an error, we will return an empty array. In the do, we will first need to create our correct answer and turn this string into an attributed string because the API might return some markdown for the answers as well. So we will do try attributed string, and we need to pass the markdown, which will be our correct answer variable. Then we will need to create an instance of answer because the answers is an array of answer. So this will be the text for the answer, and since this is the correct answer, the is correct value will be true. So let's create an instance of answer, and we will need a text as well as an is correct value. So let's simply cut this and paste it in the place of the text. And since this is the correct answer, the is correct value will be true. And then let's save this in a correct variable. and we will wrap our entire correct answer in an array so that we can easily concatenate the correct and the incorrect answers together into one array. Right below that, we will need to map over the incorrect answers, and then for each one, we will create an answer instance. So we will do incorrect answers dot map, and then we will get each answer when we iterate over it. And we'll need to create an instance of answer for each one. So for the text as is the same as for the correct answer. So we will do try attributed string, and we need to pass a markdown, which will be the answer that we are iterating through. And the is correct will be false. Now you can see that Xcode is complaining that we'll need to add a try because this might throw an error. So let's add the try keyword. And then we will save that in an incorrect variable. Now in Swift, we can easily concatenate two arrays together. So let's create an all answers array, and it will be the correct array plus the incorrect array. So this will merge the correct and the incorrect answers together. Now, if we don't shuffle these answers, the correct answer will always be the first one in the array, and that's not what we want. We want them to always be randomized. So we will do return all answers dot shuffled so that it's always shuffled and the correct answer is not always the first one. Now it's finally time to create our TriviaManager. So under the Trivia Game Demo folder, we will create a new file, and it will be a Swift file. We'll name this file TriviaManager. Inside of this file, we'll need to create a class called TriviaManager, which will conform to the Observable Object Protocol. Inside of this class, the first function that we'll create is the fetchTrivia function. So function fetchTrivia. On the first line, we will need to add a guard statement. So we'll do guard let URL will be a URL, and we need to provide a string. And if we don't have a URL, we will throw a fatal error that will say missing URL. So head over to the OpenTrivia API website that you can find in the description below, and you will be able to generate a link to call the API. So I will simply copy this one and then paste it inside of the double quotes. Now we'll need to create our HTTP request asynchronously. So to make it work asynchronously, we will need to add the async keyword right after the parentheses of the function. Then we'll need to create our URL request, which will be equals to URL request, and we need to pass a URL. Right below that, we will need to wrap everything in a do catch statement because we might run into an error. So we want to catch the error if we ever run into one, and we'll print it. So error fetching trivia, and we'll print the actual error. In the do, we will need to try await URL session dot shared dot data for the URL request that we created. So I'm going pretty fast here, but if you want to learn more in detail how to create an HTTP request asynchronously, you can head over to this link here, which explains more in detail how to create an HTTP request asynchronously in Swift. So we will need to save what we get in return in a data and the response variable. Then right below that, we will add a guard statement, and we want to make sure that the response is of HTTP URL response type and that its status code is 200. Otherwise, we'll throw a fatal error that will say error while fetching data. If we pass the guard statement, we will create an instance of JSON decoder. So we'll do decoder is equals to JSON decoder with parentheses at the end. Then we will need to set the decoder.key decoding strategy and set it to convert from snake case. This will tell Swift that in the API, we have some coding keys that are in snake case, so all in lowercase with an underscore between each word, and it will convert them into camel case so that it follows our model and it won't throw an error that it cannot find the coding key. Right below that, we will try our decoder and call the decode function. The type in which we want to decode our data is the trivia model that we just created from the data variable that we got on line 17. And let's save this in a decoded data variable for now. We will need to save the results that we get from the API into a variable inside of our class. So at the top of this class, we will create a private set var trivia, which will be an array of trivia.result. And by default, we'll set it to an empty array. We're not publishing the trivia variable because we'll create other variables later on to get the current question and answer choices, and those will be published. So we'll also need to save the length of the array, or the number of questions that we fetch, into a length variable. So let's create a publish variable, private set, meaning that we can only set it within this class. Var length will be equals to 0. Then let's go back to our fetch trivia function, and we will need to call this patch queue .main.async. We need to add that because we won't be able to publish changes on the background thread. We'll need to publish them on the main thread. Inside of this closure, we will set the trivia. So since we're inside of the closure, we will need to do self.trivia is equals to our decoded data dot results. We'll also need to set the length variable, so self.length will be equals to self.trivia.count. We will need to call our fetch trivia function on initialize of our TriviaManager. So let's add an init. And because the function is asynchronous, we will need to call pass.init, and inside of this closure, we will await fetch trivia. We'll need to add a few functions to our TriviaManager. This function will allow us to navigate to the next question, update the progress, and calculate the score. Let's start with a function called go to next question, which, as the name says, goes to the next question. But let's create a few new states at the top first. The first one is an index, and it will also be published because we will need it in our view. And this will let us know the current index we're at in the results array of the trivia. By default, it is set to 0 because by default, we want to start with the first question of the array, which the index is 0. We'll also have another published variable, which will be called reachedEnd, and set it to false. This variable will let us know if the user reached the end of the array, or in other words, they reached the end of the game. Now, right below our fetch trivia function, we'll create another one, and it will be go to next question. Inside of it, we will check if index plus 1 is smaller than the length of the array. If it is, then we'll increment the index by 1, and we'll be setting a new question here, but we'll take care of that later on. If the index plus 1 is not smaller than the length, meaning that it is equals to the length of the array, that means that the user reached the end of the array. So we'll do reachedEnd equals to true. Now we will code the setNextQuestion function. We'll need to create a few other variables at the top of the class. So we will need to create a publish private set var called AnswerSelected. And by default, it will be false. This one will let us know if the user selected an answer. Next, we will have a publish private set var question. This will be an attributed string variable, and by default, it will be an empty string. We'll also have another one, and it comes hand in hand with the question, which will be the answer choices, and it will be an array of answers. By default, it will be an empty array. Finally, we'll have one last variable, which will be progress, and it will be of CGFloat type. By default, it will be equals to 0.00. You will see an error that Xcode cannot find the type CGFloat. That's because CGFloat comes with the SwiftUI package, so we will need to import SwiftUI at the top of this file. So now you can see that we have quite a few variables, and that was what I meant when I said that we need to code a lot of logic. Let's go to the bottom and we'll create the function called setQuestion. The first thing we need to do inside of this function is to set the answer selected state back to false in case it was previously set to true. And then we will need to calculate the progress of the user. So to calculate the progress, we will need to do index plus 1. Let's add that in parentheses, divided by the length, and times the width of the progress bar. If you remember, we hard-coded the progress bar max width, and that was so that we can easily calculate the ratio of the rectangle on top that we should display in our UI. So we will do times 360. So you will see a few errors now that it cannot assign value of type integer to type CG float. To fix that, we will need to wrap our length in a double, as well as our index plus 1. And finally, we will need to wrap everything in a CG float, since the progress is of CG float type. Right below that, we will need to check if the index is smaller than the length. If it's smaller than the length of the results array that we got from the API, we will need to set the next question. The first thing we want to do in this if statement is to get the current question. So let current trivia question will be equals to the trivia variable that we created on line 12 and that we set in our fetch trivia function inside of the dispatch queue. And we want to access the question at the index that we set in our go to next question function. And then we'll simply need to set the question and the answer choices variable. First, question will be equals to current trivia question dot formatted question. We want the formatted question and not the question because the formatted question will convert the markdown into readable text. And then for the answer choices, it will be current trivia question dot answers. Now we will need to call the set question function at two places. So first, let's remove the comment in our go to next question and call our set question. Then we'll need to call it in our dispatch queue. Right after setting our length, we will call self.setQuestion. We need to add a self because we're inside of the closure. So now we need to code one last function inside of our TriviaManager, and this will allow us to update the score and set the answer selected to true. And this function will be called selectAnswer. We need to provide an answer to this function, which will be of answer type. The first thing we want to do is to set the answer selected to true so that we know the user already selected an answer. Then, if the answer dot is correct is true, so that the answer is true, we want to increment the score. So right now we don't have a score state, so let's create that. It will be at publish private set var score, which will be 0 by default. And back in our function, we will do score and increment it by 1 if the answer is correct. Okay, so now we're finally done with the Trivia Manager, and we'll need to connect it with our UI. So first, we'll need to initialize an instance of TriviaManager as a state object in ContentView. So let's go there. And at the top, right before our body variable, we will initialize a state object var, which will be called TriviaManager, and it will be equals to TriviaManager with parentheses at the end so that we can initialize it. Then we'll need to add an environment object in our question view, our trivia view, as well as the answer row. So let's go to question view, and at the top, we'll add environment object var trivia manager, which will be of trivia manager type. Don't forget to add the environment object modifier to your preview and to initialize a trivia manager instance only for the preview, so that the preview won't crash when you try to resume it. We'll just need to do the same for the trivia view. So let's paste the environment object here. We'll need the environment object modifier for our preview, and the same for our answer row. So at the top, we'll paste the environment object, and for the preview, we will add the modifier and create an instance of Trivia Manager. Let's go back to Content View, and you can see that we have an instance of Trivia View here. So we'll need to add the environment object modifier and pass the Trivia Manager instance that we created on line 11 to this view. And let's go to Trivia View, and we will need to do the same for our instance of Question View here. So environment object, and we need to pass the environment object variable from line 11 to our Question View. And finally, we will need to do the same in our answer row in the Question View. So let's go to Question View, and on the answer row, we will need to add an environment object, which will be the TriviaManager. We'll do the same for both of the answer rows, but later on, we'll simply need to do a for each, and we'll just have one answer row in our code, and we'll just need to add one time the environment object modifier. Now that we connected our TriviaManager to all of the views that needed the TriviaManager, we will add the functionalities to our answer row. So go to the answer row file and we'll add some dynamism to our answer row. So on tap gesture of our answer row, we want to check that if !TriviaManager answer selected, then we will move the is selected inside of the if statement, and we will call our TriviaManager.selectAnswer function and pass the answer variable that we have in this answer row. So what this code means is that we only want to set the is selected state and to select an answer only if the user did not select an answer yet. So only if the answer selected state is false. Then we'll also want to change the foreground color of the H stack. So we already have a ternary operator in the foreground color, but we will add another one. What we can do to make it easier to read is to wrap the current ternary operator in parentheses, and then we'll call our TriviaManager.answerSelected. If the answer is selected, we will check this ternary operator that we already added before. Otherwise, the foreground color will be our accent color. So that means that if the user did not select an answer, the foreground color of the answer row will be our accent color. If they did select it, and if the current row is the one that the user selected, the color will stay the accent color, otherwise it will be grayed out. Now let's go to our question view. Instead of hard-coding the current progress of the user, the question, and the answers, we'll use the variables from our TriviaManager instead. So at the top, inside of the H stack, instead of hard-coding 1 out of 10, the first thing we will do is to remove the 1, and instead of that, we will display our TriviaManager.index plus 1. Since the index starts with 0, we want to do a plus 1 so that it starts with number 1 and not 0. And instead of hard-coding 10, because we might not always fetch 10 questions, we will display our TriviaManager.length variable. Then on the progress bar, we will call our progress variable from our TriviaManager instead of hard-coding a 40 here. So we will do TriviaManager.progress. Now, inside of the VStack, we will replace the hard-coded question and answers with the ones from our TriviaManager. So the question is pretty easy. We will remove the string and call our TriviaManager.question. So you can see that we don't see anything because by default the question is an empty string. But don't worry, because we can build it in the simulator or in QuestionView and we will be able to see the question. Next, we will need to iterate over all the answer choices variable from our TriviaManager. So let's remove these two answer rows here. And instead of that, we will iterate. So we'll call the for each and we'll iterate over our TriviaManager.answer choices. We need to provide an ID, so it will be the ID that we set for each answer. And we get an answer when we iterate over this array. So for each answer, we want to display our answer row. And we need to pass an answer to our answer row component. So luckily we have an answer because we're iterating through it. And remember to add the environment object and pass the TriviaManager to the environment. Right now we can't see anything because the array is empty and the question is also empty. But we can go to QuestionView and resume our preview here. So let's click on Let's Go. And we are able to see the question and the answers here since we initialize our TriviaManager here. Let's go back to QuestionView and we have one last thing to add, which is the action on our primary button. So let's wrap that in a button. The button has two closures, the first one being the action and the second one the label. Let's move our primary button inside of the label. And for the button, we will call our TriviaManager.goToNextQuestion function. Because when the user taps on this button, we want to set the second question and then the third, etc. We also want to change the primary button background color if the user did not answer the question yet, because we don't want them to navigate to the next question when they didn't answer the question. Let's also pass the background argument to our primary button. So we will check if the TriviaManager.answer is selected. If it's selected, they will be able to navigate to the next question. So the background color will be our accent color. Otherwise, I will add a gray with some opacity. You can copy this one or simply set your own color. And we'll also need to add the disabled state to our button. And we want it to be disabled if exclamation mark TriviaManager answer selected. So that means that if the answer is not yet selected, this button is disabled, and when the user taps on it, nothing will happen. The action will be disabled. Now let's go back to our trivia view. We want to update the view by displaying something else on our screen if the user completed the game. So we want to code an end screen. Let's add an if statement, and we want to check if TriviaManager.reached_end is true. If you remember, in our Trivia Manager, we set the reached end to true if the user reached the end of the trivia results array. Otherwise, if the user did not reach the end, we will show our question view. Inside of the if statement, we will add a vstack with some spacing of 20 pixels. We'll also add a few modifiers to our vstack, so the foreground color of everything in this vstack will be our accent color. Then we'll also add some padding and a frame with a max width of infinity as well as a max height of infinity as well. We'll also need to add a background color, which is the same that we have in Content View and in Question View. So I'll simply go to Content View and copy this background color and then paste it to this vstack. So right now, since the reached end is false by default, we won't be able to see what we're coding. We can comment out the if statement and the else statement as well for now, just so that we can see what we added to our end screen. Right now you can see that it's simply a background with nothing inside, so let's add something. We will add the trivia game title, and let's add the lilac title modifier that we coded in our extensions file. Right below that, we will display another text that says, "Congratulations, you completed the game." And let's add a little emoji, so I will add this one, a party emoji. Right below that, we will display the score of the user. So we will say you scored, and we will get the score from our TriviaManager.score variable out of, and this will be the number of questions that we got from our trivia. So we'll call our TriviaManager.length. Right now you can see that it's 0 out of 0 because the default value for score and for length are 0. Right below that, we will add a button. So let's add the button with a label. The label will be a primary button, and the text will say play again. In the action for the button, we will refetch the trivia again so that we have another trivia game for the user, because we don't want them to always play the same trivia game. That would be boring. Since the fetch trivia function from our trivia manager is asynchronous, we need to wrap it in a task init closure, similar to what we did in our init function here. So we'll do task.init, we add a closure, and we will await TriviaManager.fetchTrivia. Remember to uncomment the if-else statement. Now when we refresh our trivia, we will want to reset some states in our trivia manager. So let's go there. And in the dispatch_queue.main.async, right before setting the trivia, the length, and setting the question, we will need to reset the index, the score, the progress, and the reach end value. So self.index will go back to 0, self.score will go back to 0, self.progress will go back to 0.0, and self.reachedEnd will go back to false. So we are resetting all of this every time that we fetch the trivia, because when the user starts a new game, these should be the default values. So once you build your application, the first thing you should see is the welcome screen that we coded. And when you click on the Let's Go button, it should lead you to the question view with the first question that you need to answer. So the first question that I get is, what country is the Husaria supercar made by the car manufacturer Arinera assembled in? So I don't know the answer to this question. So I'll select anyone, let's say Poland. Oh, it's the right one. Okay. And then we click on next, and the progress should be updated as well as the number at the top here. And you should see another question with the possible answers related to that question. So I will simply go through all the other questions quickly so that we can reach the end screen. And then I reach the end screen. So I had a pretty bad score. I scored 1 out of 10. And when you click on play again, it should go back to the question view and you should be able to see another set of questions and play the game again. So if you were able to reproduce all the steps that I described and you were able to play the trivia game without running into any bug, congratulations! You just created a trivia game all in SwiftUI from scratch. So what lessons can be learned from building a trivia game app? First, we learned, or revised, for those of you who already know that, to call an API and decode JSON data into Swift data that we can manipulate easily. We also learned how to create new coding keys or variables in our models by directly setting them when creating the model instance. Moreover, we learned that quite a lot of logic is required to build a SwiftUI game. This app also shows us how versatile SwiftUI can be. If you followed my other tutorials, we built a wide range of apps all in SwiftUI and all related to different subjects. I hope that you like coding this application with me, and as always, there's a lot more that we can cover to make this application even better, but I will leave it to your imagination. Now go ahead and build some amazing trivia game applications in SwiftUI.